Hello everyone, in this Thierry Sicard tutorial number 32, we will review the International Unit System, where the Coulomb became the electric charge unit to replace the Franklin. We will also discuss about the 1 over R or 1 over R square in the Coulomb formula. Then we will do an analogy between Coulomb and Newton's laws. In 1668, John Wilkins proposed a universal length based on the half period of 1 second of the pendule of 0.99 meter length. In 1795, the meter is defined as the 1 over 10 million between boreal pole and equator. The system CGS, centimeter, gram, and second, is proposed by the British Association of the Advancement of the Science in 1874. The electrostatic unit system EUS is based on the CGS system. To simplify the system, we state K equal 1. So in the electrostatic unit system, F equal Q prime over R square, with F in dyne, R in centimeter and Q in Franklin. But it was not logic to simplify the Coulomb's law to use only in electrostatic a different unit. Also, it was decided to use the Coulomb for the electric charge and be resigned to use epsilon 0 equal 1. In 1946, it was decided to use the internal system MKSA for meter, kilogram, second, and ampere. Define K was a huge problem to select the electric unit system in the international system. But as in the Gauss theorem appears 4 pi at the numerator, they decided to pose K equal 1 over 4 pi epsilon r epsilon 0. So the Coulomb force formula becomes F equal Q prime over 4 pi epsilon r epsilon 0 r square. Now in the electric force appears the sphere area 4 pi r square, which is in the Gauss theorem. Epsilon 0 is equal to a capacitor by meter of 8.8 picofarad by meter. Now in the MKSA system, the Coulomb became the electric charge unit, which can be derived from the other fundamental dimensions as ampere and second with Q equal IT. On the right, you can see the correspondence between the electrostatic unit system and the new MKSA unit system. Coulomb, as a great experimenter and a good mathematician, was able to find the mathematical equation to quantify the electrostatic force. Unfortunately, when Coulomb passed away in 1806, he was not recognized as the author of the mathematical law of the electrostatic force. Until 1825, some scientists refused the law in 1 over R square and proposed a law in 1 over R. Even if nobody discussed the Newton law in 1 over R square since 1687, even if in the Gauss theorem in 1813 the R square was linked on the sphere area 4 pi R square, and even since Euclid 325 before Christ, scientists knew that light intensity varies as the inverse of the distance to the source in 1 over R square, some scientists refuse the Coulomb's law in 1 over R square. Hopefully, other scientists as Biot and Poisson spent a lot of energy to defend the value of the Coulomb work and give in his honor his name for the electrostatic law and later his name for the electric charge unit. As Coulomb was inspired by the Newton's law, it is interesting to compare the order of magnitude between electric and gravity forces. The ratio Fe over Fg is huge, and for sure in the atom the gravity is negligible compared to the electric force. In the analogy between Coulomb and Newton's law, we have first the vector electric field E and the vector gravity field G. Both electrical field E and the vector gravity field G gives F equal minus QE and P equal mg. With the Gauss theorem, we can get the electric field E equation where we find the sphere area for pi r square, which includes the punctual charge plus Q. But nothing will change for the electric field E at the distance r from the center if all the electric charge was spread over the complete sphere volume. On the same way, the Earth's area 4 pi rt square appears on the gravity field equation, where the sphere includes the mass of the Earth. As in the atom, if all the Earth's mass was concentrated at the center of the sphere, the gravity field at the distance rt will not change. So, in both cases, the term r square is coming from the area formula. I want to thank you for your attention. On my next Thierry Sicard tutorial number 33, we will talk about the birth of the electromagnetism with the Ørsted experiment, which allow Ampere to do the Ampere's law. So see you soon and stay tuned.